Hello everyone, welcome to the Maths Union LaTeX workshop. So I guess a bit of an intro on, I guess this is the structure for the talk. So we're going to go through what is LaTeX, what is it, why do we use it, getting started, and then kind of going through to concluding remarks as well. So why LaTeX? Why bother with it? LaTeX is the gold standard for formatting maths pretty much. And many apps also support LaTeX, so that's whether that's Notion, Markdown, on Discord, or pretty much any website as well that supports maths input. It's durable, it doesn't corrupt like Word. I think one of the difficulties with Word is that sometimes you'll enter in Greek letters and stuff like that using the equation editor, and it'll just, like, you close the file, you reopen it, and it's corrupted. And then that makes it pretty difficult to work with as well. And it's also OS independent, so you can run it on Linux, Mac, Windows, pretty much anything. And one of the really nice things about LaTeX is also you have the separation of content, what you're writing, from the style of your document, right? So basically separating out, like, you have like sensible defaults, and you can like specify the content, and then the styling is specified separately, and it has some sensible defaults as well. It'll become clear once we actually go through some examples, but it automatically places tables. You can swap out styles easily. So say I'm writing for a journal, and the journal has their styling. Like, changing to their styling can often just be the switch out of one line, and then just automatically converts everything to their styling. And the styles also just look great by default. And we can also separate our files easily into we can separate our documents into multiple files and make it really easy to write books and stuff like that, because we can just have a file for each chapter and then worry about the chapter's content within there. And then all of that pretty much makes this really good for academia, because really good maths formatting, like separation of content and styling, as well as making it easy to manage different parts of the document. So most papers in engineering, maths, and physics are written using LaTeX. So yeah, I guess the difference between LaTeX and Word is LaTeX is a markup language. So it's kind of like a coding language, but that can be compiled to PDF using a LaTeX engine. And I guess the key thing here is what you mean is what you get, right? So you basically tell LaTeX what you mean, specify all the content, and then it will convert it across, whereas Word is more of a visual editor. And then where can we write LaTeX? That's either online or locally. So online is what we're using today. We'll be using Overleaf. But you can also get local installations, which take a bit more setup. So that's stuff like MikTeX. You can also get integration for VS Code or other installations as well. And you may be wondering why I'm saying LaTeX. Valid pronunciations include LaTeX, LaTeX, or LaTeX. So a bit more confusing than it needs to be, but that's why. I don't know, I just prefer LaTeX. Cool. And when shouldn't I use LaTeX? Because I think that's also an important thing to go over. Basically, like, in my opinion, if you're writing a lot of maths working, like huge amounts of maths working, and it's just like kind of, I mean, writing on a scrap piece of paper or writing just on paper and scanning it in is probably quicker for your assignments. And also, if you want like absolute control over your styling, since LaTeX kind of separates the styling from the content, and you want the control over the styling, then maybe not use LaTeX and maybe go for something else like, I don't know, Word or Publisher or stuff like that. Cool. And I guess before we start as well, if you forget everything in this workshop, just remember these resources. So LaTeX Wikibook, insanely helpful resource that I found when writing this workshop as well. Detextify, which is a website where you can basically draw a symbol and get its corresponding LaTeX command, and various cheat sheets online, as well as all the materials for this workshop. And that's also the source code. So that pretty much links to an Overleaf document, and then you can check out also all the source code for everything in here. So these slides as well were written in LaTeX. Awesome. Any questions before we get started? No, cool. Awesome. So pretty much our first LaTeX document, this is what you can write. So what we have here is document class, A4 paper, 14-point article. We're specifying the title, author, and date. We're beginning of the document. We have make title. We have a section and then text here. So basically, without getting too in depth, because we'll explore this later in the workshop as well, in general, there's kind of two sections to our document. There's this up here, which is a preamble before a begin document. And this is where we specify everything that, I guess, information regarding our document. So we can specify its title, its author, its date, and we can also specify any functions that we want to define ourselves, or use any packages as well. We can import them up here. Document class at the top basically tells LaTeX what sort of document this is, and then that also specifies what sort of environments we can use, which we'll delve into. We have begin document here, and end document, and this basically specifies our document, where it begins and ends. So we'll just get into, I guess, the command side of things. In LaTeX, backslash is used to distinguish commands versus content, right? So, and this will be clearer in the next few slides as well. So basically tells LaTeX, a command is basically telling LaTeX basically how to format the content as well. Is curly braces as well, so a typical pattern will be like slash command name and then curly braces will specify the arguments that that command takes, and the % sign is used for comments. So comments is like stuff that won't actually be rendered to LaTeX, so we can actually put notes to ourselves in that as well. Just in terms of special characters, these are the characters that in LaTeX by default, if you like try typing them, they'll kind of like have a special use, if that makes sense. So if you try typing a $, like if you want like $20 or something, by default, they'll enter math mode. So in order to escape that, if you want to actually write $20, you need to do backslash in front of it. So those are the special characters and the way that you escape them. For those bottom two, it's a bit weirder because by default, by doing backslash caret, it's actually putting like a caret accent on like an N or whatever. So if you do backslash caret and then N, it'll put an accent on that letter. So putting curly braces after that will like negate that accent. Anyway, that's a bit of edge case there. So when we look at commands, we're thinking, I guess commands can come in two different flavors really. There's macros, which are activated just by starting with a backslash and then the command name. And then there's environments, which are basically blocks of code or blocks of LaTeX that will be formatted a specific way depending on that environment. So yeah, macros begin with backslash, and they sometimes require arguments, which we pass in using curly braces, or optional arguments as well, which we pass in using square braces like that. Yeah, so in this example here, we begin this math environment, and then by beginning that, what it's telling LaTeX is everything inside that block will be entered using math mode. And yeah, we'll delve more into math mode at kind of the second half of the slides. But yeah, that's how we can begin and end environments. There's multiple different environments that come by default in LaTeX, and there's also multiple environments that we can kind of import into our LaTeX environment as well, into our LaTeX file as well. So these are just some of the things that you can use in LaTeX to kind of expand its use. By default, LaTeX is quite slim, so like the coloring of stuff and like I guess to tune page sizes and margins and to tune like colors of things and insert hyperlinks and stuff like that. You just need to import these packages. But once you import it, then it kind of brings those commands into the into your LaTeX environment for you to use. And there's lots of LaTeX packages that you can use, like much more than this. So there's, I think we can discuss that after. But there's stuff for you to like even write to-do notes in your presentation and in your reports and stuff for them to be formatted to PDF. Any questions regarding commands? I know that it might be a bit, what's the word? A bit like spooky at the moment, but we'll, yep.
Do you want to maybe put up like an example, like in overlay for that?
Yeah, can do that. Of
like using these commands or environments.
LaTeX example or?
Yeah, or if you want to make like a blank.
I'm just thinking what environments we use that isn't a math environment.
I mean, so like arrays, tabular, tables.
Oh yeah. Yeah, we can pull up a table. I guess. So just as a bit of an example here. Trying to zoom in on this thing is. How do you zoom in? Okay. So I guess this is a bit of an illustration here. So this is a table environment. And what we have here is, here we begin a table, and then we're specifying here where we're positioning. So the H by default, is that top or?
It just means here. So
Oh, right, yeah. Just place it here. So we begin tabular, and this specifies the columns that we're using. So we're using a left-aligned, a center-aligned, and 3 center-aligned columns. And then each of them is separated by a line. And then here we're actually laying out our table. So we have our first row, which is product A, B, and C. And they're separated by AND symbols there, in order to specify the different cells, and then we're going to new lines and adding horizontal lines in between. And then that outputs this table here, and the fact that we put it in this table environment and we put a caption at the bottom and label this just allows us to reference our table throughout our code as well. So I guess that's an example of an environment. If we're thinking of like commands themselves, we also have bullet point environments as well. Like we can also have something. I'll just quickly mock up at the bottom, but. Like the itemized environment, and this allows us to have different bullet points. Like that. So if I scroll all the way to the bottom, is this showing up? I don't know why that bullet point isn't showing up. At the very bottom? Oh, there we go. Sorry, yep. Any questions regarding commands and environments? I think we'll go through some more examples in the next few slides as well. Just some comments about using overleaf in general. So by default, we have quite a few folders here. So we've basically got 3 different LaTeX documents within one project. But if we go up here, I'll just go, by default, you have this view. You can create a new project, like an example project. And you're brought into this this view where you have like a main.tex file, and then we've got some stuff here. Since I used the example template, it kind of pre-populates it with a bunch of stuff, but you can also have a blank template as well. But the default use is just there's a main.tex file, and then in order to compile that, you can press the recompile button, or you can do Control-Enter. And in order to comment out lines, you can also do Control/, and then they'll add a comment, a % sign at the beginning of that line. And you can also do it with like whole sections if you select it. And then in LaTeX as well, you can go Menu and show your hotkeys as well to, I guess, show you everything there. Okay. So we'll go into basic writing. When we're formatting our text, so I guess there's 2 distinct modes in LaTeX. There's math mode and there's writing text, right? So when we're formatting text, there's different ways that we can format them, and there's for this in particular, there's I guess 2 different types of commands. A lot of macros for text formatting, they come in pairs. So there'll be a command for the use case where we do /command and then put the text in the middle, and then there's also some commands also have this equivalent switch command, which basically means that if we put that switch command in an environment or like a grouping, then it will basically turn all the text in that grouping with that switch command. So the way that we can use that is to just put curly braces like that and then put the switch command inside there. So this is just an example of the stuff that you can do. So in order to change font size, you can use /tiny, script size, small, large, huge, right? And then you can get varying sizes for your text. And then that acts as a switch command or a normal command. And you can also change font style. So using TextBF for bold font, TextIT for italics, small caps, and then, yeah, we also have different font families as well. In LaTeX, if you just highlight text and do Control-B, it'll identify that as wanting to convert it to bold, I think. So it automatically puts TextBF there. And same with italics. So just an example here. So this example requires the Xcolor package. So this can be done just by importing Xcolor at the top. So it'll just be something like use package Xcolor. Is it Xcolor or X?
It's with OW.
Oh, of course. Yeah, use package Xcolor. Oh, sorry. And then, so that's how we can change the coloring of specific words. So we can do /text color red words. And then this is an example where it comes in pairs, because if we want, we can also specify whole blocks of text to change color by putting them in parentheses, sorry, not parentheses, curly brackets, and changing the color that way. Yeah, and then we can also get more particular with our types of colors as well. And yep, using itemize. Yeah, so we can also create ordered and unordered lists using /enumerate, itemize, and description. yeah, so enumerate for unordered lists, itemize for ordered lists, and description for long paragraphs. I'll pull up a blank document actually. So in this instance here, we can do begin enumerate, and then we can have item 1, item 2, item 3. And that would be the output for that. And we can also nest these sort of bullet points, and we can also change the item used for the bullet point. So I guess in the context of itemize, I think I'm not entirely sure if it works with enumerate as well. Yeah, with enumerate we can kind of override the bullet style as well manually by giving that optional parameter. Okay. Oh yeah, and then there's an example here as well. Any questions regarding that? No. Okay, so as we saw earlier, often we specify the title, author, and date. We do that in the preamble after we've imported our packages, and then in our document we can do /make title, and then that will format, basically insert the title, author, and date in our document at the top according to the style that we have that we're using. So a lot of the time you'll be just using the article document class because I guess that's just like an easy default to use. And then in this case, our title is blank notes, author UWA Maths Union, date May 2022. If we don't want the date, we can also just remove that, and then it doesn't print it out. A page of contents can be compiled using table of contents, so that actually uses the section headings and the subsection headings that we've specified throughout our document. So that's automatic, and we can also specify an abstract using begin abstract, and we can also do further customization if we want to using the begin title page environment, which I guess if you want to get more into the nitty-gritty sort of details on your title page. Yeah, so here we have /section, section, /subsection, and sub-subsection. So in this instance here, we have an introduction section, but we can also have a subsection within there. And a sub-subsection in there, if I spell it right. And we can also suppress the numbering here by putting a star at the end of that. So kerning really, I guess it's more for advanced use, but it's mainly how we can have control over the spacing between characters in our LaTeX documents. Because the way that LaTeX works is that it will actually squish down multiple spaces into one space. So this allows us to, I don't know, fix positioning both in math mode and in text mode if we want to make it a bit wider between items or a bit narrow between them. There's a link there for those interested, but to be honest, I don't really find myself using kerning that much, at least not often. and not throughout your document, unless you're very particular about the styling that you want to use. So slash space, slash colon, slash semicolon, and that sort of stuff gives increasing spaces between words. So that's also another way to control it. We can use slash v space and slash h space to specify distances between items as well. So if we want distances between paragraphs, and what that takes is a length inside of it. So lengths can be in centimeters, in inches. We can also specify like 5 characters tall kind of thing, right? So if I have this introduction here, we can see that there's a bit of spacing between introduction and part 1. But if I want more space, I can do slash v space. And then that can take in like 2 centimeters or something along those lines. And we can see it's shifted down 2 centimeters. We can also do 2 inches. Similarly, that has the same effect. And 2m. In this case, we'll do 2 characters tall. So that's, I guess, how we can have finer control of the spacing in our document. H space works in a similar sense as well, just horizontally. And we can also do fractions of the text width and page width. So by default, I think autocomplete is messing with me, but I think this might work as well, unless it's paper width. Yeah, paper width also works. So paper width and text width. And they'll become particularly useful once we get into placing figures, because sometimes we'll want to place a figure and we want to take up half the width of the page. That's just a really easy way to specify it as well. So yeah, double slash by default. So when we use double slash in our double backslash in our LaTeX document, that enter line and starts another. Slash new line will insert a new line altogether, and slash new page will create a new page. Slash clear page will also display all the images before it starts a new page. Any questions regarding that? I think when we're looking at LaTeX, I guess like doing a presentation on it is it's a bit overwhelming at first until you actually start writing your own document. Because once you start writing your own document, you realize that a lot of the stuff you only use like 10% of it until you actually need to, and then you'll look it up how to use it, and then you'll use it from there on. But I think the main thing really to be aware of with LaTeX is how it's structured. And once you're aware of how it's structured and how everything fits together, then it's easy to learn new things. Because I found when I first learned LaTeX, I learned like 2 commands, or like very superficially. I didn't actually understand how LaTeX worked, and then it meant that I was like running into brick wall after brick wall, and then it's like, I guess, a slower learning. So if you're able to understand how LaTeX works and how all the pieces like come together, then learning new pieces is pretty easy. I guess going to the maths part of it, which I guess is the more exciting part, there's different ways that we can. The reason that LaTeX is really nice is like the ability to have absolute control over the formatting of your maths, right? So a lot of you may have already seen the $signs. So there's different ways that we can enter maths into LaTeX, basically entering math mode. We can do it inline. So if we have a paragraph and we want to specify some maths like inside our paragraph, like x equals 2 or delta equals like setting constants. We can do that inline, or so we can do that inline, right? So there's 2 different ways that we can write inline. 3 different ways. We can use a double $sign. So that's $sign, write our maths, $sign at the end. This is from Tech, which is basically the predecessor to LaTeX. It still works. However, it's a bit outdated, and I guess the newer approach is to use parentheses. The main difficulty with $signs like this is if you forget a $, then your document won't compile. And it's a bit difficult to hunt down if you aren't, if you forget to close your $. I don't really know what adding parentheses does to it, but I don't know why they change it. Anyway, you can also do begin math, so that will basically, any maths that's written inside that environment will kind of be formatted into that paragraph. We'll go through an example just now in the overleaf documents as well. And then we can do block equations as well, using double $ either side, or by using square brackets as well, backslash square bracket, backslash close square bracket. And then we can also begin display math environment. We'll go over multi-line equations, which in my opinion is one of the best features in LaTeX. And then, we'll go over the inline environment for that. And then by default, your block equations, they won't actually number the equations. So if you want to do that, you can do backslash begin equation, and that will actually number it, and then you can reference back to those equations. So then in your paragraph, you can say in equation 1, and then you can refer to those equations like so. You can also suppress numbering, but then that's a bit like, if you're suppressing numbering, might as well use display math. Cool. So this is an example here. This is an inline maths equation. We've done backslash open parentheses and backslash close parentheses. And then inside here, we've actually written ourselves some maths in LaTeX. We'll go through some of the stuff that you can use to format it, but /phi inputs a phi character. /sign, it displays sign upright because by default, all letters in a maths environment are formatted as variables. So sign, of course, here isn't a variable. And then /theta here is to specify the theta there. We can also do a block equation. And what we're doing here is /frac. What that does is, so if I display a block equation like so, the first argument is the numerator and the second argument is the denominator. So going back to here, we have a fraction with the numerator being -b plus or minus, so that's what the /pm means, the square root of b squared minus 4ac, and then all over 2a. So I guess once you get the hang of it, this makes it really easy to just write any equation, because you can think up equation and then write it correctly. And I guess you don't have to use your arrow keys or search in a GUI for commonly used symbols and stuff like that. We'll go a bit more over the different symbols available to you, I guess, in the demo portion of the workshop. But you can also find cheat sheets online that just basically list all of them, and you can get familiar with that as well. But the thing is with Greek letters, you just need to know the spelling of the Greek letter, and then you can put it in there. For stuff like epsilon, there's actually different variants in LaTeX. So if I do /epsilon, we can see that uses that epsilon, but if we do /var epsilon, it gives us a different variant as well. So I guess a bit of a more curly one. You also have /pi and /varpi, which, I mean, I've never really seen /varpi used in any literature, but oh well. It's there. There's also variants for theta as well. I think, so you have /theta and /var theta. And yeah, /var theta is a bit cursed. Anyway, so that's how you can write Greek letters in math mode for LaTeX. I guess going into multi-line environments, I think this is really powerful here. So you do /begin, a line, and then star. What this star does is it disables the numbering for the align environment. And then, and then you can specify your multi-line equation. So at the end of each line, you do a double backslash to indicate that's the end of that line. And then you start a new line. And all along here, each line of working, it'll look for the ampersand, and it'll line up your equation so that, I guess it lines up on the ampersand, if that makes sense. So you can chuck it before an equal sign or before a symbol, and it'll line up on that. So I guess going here, we can do /begin align. And in this case, it's, there we go. And yeah, in this case, it's lined up on the equals and the 2 there. Sorry. Okay. Yeah, so symbols can be accessed via macros with Greek symbols there, cheat sheet, if you'd like. And we also have multiple different options, multiple different symbols that we can use so we can integrate. What the underscore here is doing is it's specifying that this is the lower bound, and then caret upper bound. And same goes for summation there. We can also get the time symbol, C dots. Basically, any symbol that you've seen in any mathematical text, you can get. Yep, so we use the underscore there to denote subscripts and the caret to denote superscripts. And we can use curly brackets as well, because by default, if we use subscript or superscript, it'll only do the character directly after the underscore caret. So we can actually group characters together and put them all in the subscript or all in the superscript. So this is just an example here, but as we see, we have xi plus 1, and then we can have a squared, a to the n minus 1. And then we can also use them together. So just some more mathematical operators. We have sine, cos, and tan, like so. We have fractions, display style fractions as well. We have the square root, or we can also get the nth root of something just by putting that in the square brackets there. Math op, basically, it converts everything in that to an operator. So we can put dx in there, but we can also use that for like variance or standard deviation and stuff like that in order to represent that. And then /text allows us to write text in our math environment. So we also have /hat, dot, double dot, and bar, and those put the corresponding thing on top of the variables as well. Yeah, also got some more delimiters. By default, of course, the curly brackets are used to group things. So if we want to actually display a curly bracket, we need to escape that by putting a backslash in front of it. Then we can also have left and right angles and stuff like that. And also get the norm using /mid. So here we have a fraction. By default, if we just do the delimiters, it won't actually scale the delimiters up to the size of that fraction. So what doing /left and /right does in front of the delimiter is it scales that delimiter up to the height of whatever environment goes in between it, right? So we can use that for fractions in this case, but we can also use it just now when we have arrays and matrices. We can put /left and /right there for the delimiters. And we can also, if we want more control over the size of our brackets, we can also use /big, and I guess different variants here. So capital big with 2 G's, capital big with 2 G's. And then that changes the size of our brackets. So if we want to write an equation and make it clear what's inside the brackets and what isn't, then we can use varying sizes for that. And that's an example with that as well there. Okay, any questions regarding that? Yep.
The question about formatting is, so can you use the backslash square bracket in place of the backslash parenthesis for the LaTeX environment?
Backslash, so in the math mode, the reason that we need, I'm sorry, I'm not really sure I understand what your question is. Is that in the text mode? My voice is completely gone. I don't know what happened. Oh my God. Yeah, that's all good. Yeah, if you want to check it out, that's fine. Gosh, my voice. Okay. Oh yeah, we already discussed a bit the align environment, but I guess that's a better example than the one I showed in the overleaf document. So we can use the @ symbol to align on equals, as we said before, and then in this case, because normally with your environment, it'll kind of just try center everything. So this means that everything's aligned up on the equals there. We can also begin array. So what an array is basically a maths table, right? So by default, if we begin a tabular environment, it'll begin in text mode. So if we want to enter maths into our table, we need to actually format it as inline maths. So back in the other example there, like if we want to format Greek letters into our table, we need to specify we need to actually enter maths mode inline and specify those characters there. But if we want to just put maths in a tabular environment, then we can use array. And we have an example of array in the next slide. But basically, we can set the alignment center, left, or right aligned. Each cell is separated by an and symbol. Each line is separated by a double backslash. And we can also use delimiters, as we discussed before, using /left and /right. We can specify delimiters to go on the left and right of our environment. No worries. So, yeah, arrays right in math mode. So going here, we have /left bracket, so that basically scales up a left parenthesis to the height of the environment enclosed within, and then /right bracket at the end, it scales up the right parenthesis, and inside we have /begin array, 2 center aligned columns without any lines without any vertical lines between them. So that's just CC there. And then in here we have the top left cell, which is 2 minus lambda. We've got a 0, 4, and then 3 minus lambda there. And that's what outputs. And this here, Yeah, we needed to enter math environment for this because slash left and slash right, they only work in math environment. But if we just had the array itself, I don't think we needed to enter math environment. No. Yeah, okay. And so this is one way we can format matrices, but another way we can also format matrices is, so I guess this is a more general way that applies to basically matrices of any type. It's kind of like a superset of the formatting I'm just going to show just now, which is slash begin P matrix and slash begin B matrix. So P matrix is parenthesis matrix, B matrix is bracket matrix, and that's pretty much the exact same, except you don't have to specify slash left parenthesis slash right parenthesis at the beginning and end. So pretty much the exact same there. Okay, cases. So if you want to do piecewise defined functions, you can use the cases environment. So here I have a heaviside function equals slash begin cases 0, and then I've inserted some text here, just the word for, with a space at the beginning and end, and then s less than 0. So, and then I've moved on to the next line. I've done s. You can do greater than equals by doing slash geq. So and of course you can also do less than or equals using leq. Of course, if you want to do less than or greater than, you can just use the symbols on the keyboard. But yeah, what this outputs is the equation on the right. So yeah, that's pretty neat as well. So as arrays as a maths, if arrays is the maths version, the I guess text mode version is tabular. So slash begin tabular allows us to, so I guess we have this first argument, which is the environment that we're creating, and then what goes in these parentheses is the alignment and the, what do you call it, the line separating the, splitting up the table. So we have, as before, we can do LC or R for left align, center, or right align. We can do slash H line between our rows in order to specify a horizontal line. And if you want to get more into tables, there's different packages that you can use and look into. Book tabs gives you fancy rulings. I haven't really used book tabs myself, so probably not the right person to ask for that. And multi-col allows you to merge cells together. So you can specify, I guess, a larger column, and then inside there, 2 smaller columns. So that's multi-col and multi-row. I guess the difference between a tabular and table environment, when you specify slash table, you're specifying a figure. And what that means is that you can, in that, specify the caption of that table. You can specify the label for that table for it to be referred to elsewhere in the text. Tabular is actually starting the table. So it's actually specifying the columns and the data inside of it. So if we look here, I have a little comment here, which is just indicating that these vertical bars indicate that these lines here will be created. And then we have our different cells, first cell, second cell, third cell for the top row. Then in the line there, I have 2 horizontal lines. So those are those lines there. And then I have, what, 4th, 5th, 6th cell. So in the second row, we have first, second, third. And then new line 4, 5, 6 there. And then I'm finishing it off with a horizontal line at the bottom. Okay, so I think that should be, I don't know, pretty straightforward. Figures. So basically, LaTeX will place your figures for you. Normally in Word, you have to drag figures, and then you try drag it into the wrong place, and then shoots all the other figures off the page. LaTeX basically chooses where to place stuff for you, and you can specify preferences as well when you're defining these figures to have more control over it. But yeah, so I guess if you try and move floats to exactly where you want them, things can get a bit messy. So just try avoid doing that, and often you can also just refer to figure, so even if it's on the next page, the reader knows where to find it. And don't really know what this last bullet point means. Slash begin. Not sure. Yeah.
By default, tabular, it's like you can go across pages. But if you put it into table, it means that it won't be stuck between two pages. It'll only be
on one or the other. Ah, okay. And then with tabular, can you specify captions and stuff in there?
Oh, no, you have to do that table.
Ah, I see. Okay, gotcha.
No.
Oh, right. But you can just use tabular by itself, and like it's not figure, and then you can just flow it across multiple pages. Awesome. Yeah, well, we have some more examples, which we'll go through after the slides, and those are in the example, extra example LaTeX document as well, on how to reference and, well, I guess referencing is one thing, but more importantly, cite your figures. So the nice thing about LaTeX is you don't manually need to number your figures. You can just specify your figure. Like you can label, like I might, we'll show an example later, but I can label a figure Pythagoras or something. And then in my text, I can actually do /cite Pythagoras, and then it'll automatically generate the figure numbers, and it'll say, as per figure this, which in reality would be you doing as per figure /cite Pythagoras. And then that's just an easy way to kind of manage your figures, and then so you don't have to worry about manual numbering and stuff like that. When we think of, and then that also works for graphics as well, so tables or graphics. So if we want to use graphics, I can include images in our document. We use the package GraphicX. So that's to import PNG, JPEG, or PDF files from the location of from the same directory as our LaTeX file. We can do that, and we can also specify like the full path of those figures as well, if we want. So in order to do that, we just do /include graphics, the parameters that we want. Now we can specify multiple parameters. We could specify scale, width, height, angle, and we can also specify the file path. And then as we were talking before, there's different ways that we can specify the width, so different length parameters we can use. We can use paper width, text width, centimeters or inches. I think there would be other ones as well, so like /m would be for character widths. So we can have fine control over the sizes of our images. Also it's easy to put your pictures into folders, so just more organized, especially if you have multiple pictures as well. So I guess the difference here, so when we do /include graphics, it just basically plonks that image in the text. But if we wanted to be a figure, that allows us to add a caption to it as well as label it. And then that's a float environment, so then LaTeX will position that. So yeah, basically everything inside our environment will be floated, and we can specify preferences for the positioning on the page as well. Yeah. So an example here. Oh yeah. So yeah, we commonly use /caption or /label. So here, what we have is we have a figure. We've decided to center this figure. So that'll be in the center of the page. We're including the graphics, which in this case doesn't have a file name, but normally we'll put the file name in there. Then we can /caption and then put the caption in there. This will paste the caption underneath the image. If we want it above the image, we just need to move that /caption to the top, above the included graphics. And then we're actually just assigning this a label, which we can then use to reference this image throughout our document. Yeah, so we can do /ref label to reference any figure, table, or equation. And LaTeX will count figures and tables separately, as well as equations separately. Yeah. And we can also have mini page. I haven't really used mini page, to be honest, but it basically just formats things together. So yeah, so they'll align themselves next to each other as well. So if we want to raise the figures, we can use mini page for that. So we have 2 frogs there, and then this is the code for the previous figure. So we have, we've begun a mini page, placed it, begun another mini page, and then we're captioning that. Any questions regarding that? Cool. So kind of sped through the presentation a bit, but we'll use the next hour or like the remaining portion of the workshop to go through, I guess, a bit some of the examples, as well as to allow you guys to kind of test out LaTeX, kind of let this all sink in. Just a bit of concluding remarks. The best way to learn LaTeX is to practice. Look for resources online as well. We have the extra LaTeX example sheet in the workshop materials. So we have an exercise sheet and an example sheet. Just an exercise sheet to give you guys some practice, and an example sheet to kind of show you more of what's possible in LaTeX in terms of referencing things, as well as using slash, I guess, referencing things and referring to figures as well. I'd also recommend like looking through some more packages. So there's a bunch of different packages. These are just some of them. Tix is something that's also pretty interesting. It allows you to specify arbitrary diagrams in your in LaTeX as well. So there's vector graphics. And if you also want to embed code in your LaTeX documents, you can do that using listings. So that's really good for if you're programming something and you actually want to embed a whole Python file, you can just do that. The nice thing about doing it this way is it allows you to, the really nice thing about LaTeX is by outputting figures to a specific directory, those are then loaded in with LaTeX, right? So if I'm doing some analysis in Python, I can export those figures to a directory, which then LaTeX pulls in and uses that to render the document. And I can also tell LaTeX to pull in the source code from the location of that source code. So that's very different to how Word works, so you don't have to actually manually copy and paste the code in. And I don't even know how you'd format code in Word. There's also the stack exchange there, which is good. And you're also able to write your own commands. So if you're finding that you're repeating something again and again, you can pack that into a command, and so that you don't need to do that. And yeah, that's pretty much it.